we're looking at expanding quotients this time. A quotient is there inside the bracket where we have some number divided by another number. It might be numerical, or in this case it might be algebraic. So we're looking to find a rule so we don't have to expand it out. Now in this case, we've got the same sum there twice, the same expression twice, so we can show us, yes, we can do it one way if we know the numbers, but if we don't know the numbers, we have to do it a different way. So in the same way that when we had brackets with a product inside, we have to apply this value to the entire thing, every single term on the inside there. So we would be looking at then 4 squared divided by 2 squared. So 4 squared is 16. 2 squared is 4, so we'd get an answer of 4 there. If we did it numerically, because we know how to solve the part inside the brackets, 4 divided 2 is 2, and that there is 4. So we come up with the same answer, but in this case we don't know the numerical value, so we can't use this method, we have to use this method. So we're applying this index to everything inside the bracket there. So we'd end up with c to the power of 16 divided by d to the power of 16. We can't go any further because they are not the same base there. Right, in this case, we've actually got 2 terms on the top here, so we can't forget to apply that power of 2 to every single term, plus the one on the bottom there. So we would end up with 2 squared a squared on x squared, and we could take it that one step further by saying we know that 2 squared is 4, and we leave everything else as it is. Okay. In this example, we've actually got this index applying to something that already has an index. So we have to start using some other rules as well. If we think back to power of a power, we now have to apply this to something with a power already. So we're looking at a cubed all to the power of 3 divided by m squared all to the power of 3 as well. We know that our rules say that if we have brackets and we have we have numbers outside the power outside the bracket, it multiplies by the power inside the bracket. So now we're saying a to the power of 3 times 3 divided by m to the power of 2 times 3. So we are left with a to the power of 9 divided by m to the power of 6. So I've run out of room there, but it's really important to keep things nice and orderly and nice and neat so we know which ones are our powers and which ones are our normal numbers or our constant there in front of it.